Welcome to episode 18, and my name's Blades. Hello. I've struck on an idea. I've had an idea for this video that will make all the rest of the videos a lot easier. I mean, we've only got 6 to do, but something that I've been avoiding all the way through our programming, and it's maths. I'm a maths head person. I love the maths, but there are people out there, you included probably, that don't like maths. So, I've decided to do it all in one episode, get it out of the way with, and then we can just get on with our lives and get things done. Let's get this maths over with. I'm going to use maths.h. I'm not going to use the other two. Well, I will. I'll be using... I'll have to update mat4d, won't I? Yeah, well, that doesn't matter. I'm also going to have an extra include that doesn't really belong here, because I'm going to make a toolbox. And to make the toolbox, we need maths for everything. Plus, if you remember, I only did left, right, forwards and backwards for the camera, and I never did rotations. Well, that's because I didn't have a toolbox, and I'll show you why as we go. So it's up into entities, and I'm going to grab the camera as well, just so I can do some toolbox stuff for that in case you lot want to go ahead and put some rotations in there. So there's your camera.h. Yeah, that's fine. We'll give ourselves some name spacing, of course, because if you remember, maths was not in namespaced. It was just in its own little area. Well, it was in namespace amber. So I'm just wondering whether to put our toolbox there as well and not put it in toolbox. Ooh. That's a very good thought, and I think I'm going to go with it. Namespace amber, which is all we did for our maths, isn't it? So if I look at matrix mat4d, all of this is only in amber. So I think I'm going to follow suit and put our toolbox in amber, so we don't have to have a toolbox : toolbox instance, which just really wouldn't go down well with me. It'll also mean I can use inlines a lot easier, and all of these inlines will work a lot better without any complications. That's a very good idea. So I'm just going to use namespace amber. I'm going to use it in the global amber space, as it were, which is the whole of our program. So this toolbox will be able to be picked up anywhere you want. So I'm just going to, instead of making it a class or a namespace, I'm just going to put toolbox for math functionality. How's about that for a long word? Right, let's get on with it then. First one we're going to make is a static, because it never changes. Static inline returns a float, and it's going to be just called, it's a function that's just going to float around in amber, in our global amber namespace, and it's going to be called 2 radians. A lot of maths uses 2 radians, and humans like to use degrees, so we'll give them 2 radians free of charge. How's about that? Float and whatever's in degrees. Degrees. Yeah, it looks right. Yeah, that's okay. Of course, we've got all our maths functions in here, haven't we? So yeah, we can just return it. Return static cast I just want to make sure that it works out properly into a float, because I said I'm returning a float, and it is degrees times open brackets m underscore pi. What have I got here? m2 pi, m1 pi. Can I notice not? Yeah, I can have pi. Thank you. I know I've got maths included somewhere there, and really that has come from a hash include, which is, I'll put it in math .h. Thank you. That's where it's come from. So that's where mpi resides. It's a hash defined for pi to 3.141592653589793238846, and that's the number that it puts in there. There you go. It's just a hash defined. That's all it is. Nothing spectacular. And to go from degrees to radians, we just divide pi by 180 degrees. 0.0f. We can close and semicolon. I've only put the static cast in just in case. Just in case. I don't think it's needed. Is it needed? It's a float. Is everything in here floats? That's a float. That's a float. That's a float. I don't need to cast it to a float. It already is one. Okay, that gets rid of a bracket. Coming in as a float, we'll put static cast automatically onto any ints being passed in. There we go. That's what it has to do. That's nice. Okay, that's our first tool in our toolbox, and this is popping slightly, so I am. Yeah, that's better. Let's go past the pop. Yeah, that's better. Oh, lovely. That's your first one. Done. Now we're going to need a static inline. Remember, all of these have to be static as well, because we want them floating around in non-space. We don't want anybody changing them whilst they're floating around. So it's just so that we can have access anywhere from our program, from absolutely anywhere. We can just get them. It's just a part of the Amber namespace. Yes. So it's a Mat 4 inline, Mat 4. We're going to have fun with this one. What we're going to do is we are going to create the model matrix. Remember MVP? We couldn't do it because we hadn't got to create model matrix. So we're going to do that here. It's not actually too hard. It needs create model matrix needs a vec3. It's going to need a translation. I don't think we've got any of these actually. Vec3 translation we've got, right, okay. Translate. I'm just going. How do you spell this? There we go, that'll do it. Comma, getting big. Okay. We will need float. This is the actual model itself, remember. This is a matrix that we're going to be passing through to our shaders. So this is for the model itself. What would we have? We would have its translation, in other words, the position within the world. It's X, Y, Z. That's a vec3. We would have its rotation, X, Y, Z. Now I know we've already got these, so it's float. I'm just going to say rotation. Rotate. rotation and X. Does that look right? Yeah, that looks right. And then we can have rotation Y. Now I'll do a return. And a rotation Z, please. And we'll need its scale, because we have defined it. It's got a scale, usually 1, 1.0, but we do have a scale, so we can use it. Why not? Lump. Lump. There we go. That's just a function. Why is my floating wrong? Thank you. I'm designing this. You can't tell me I'm wrong in my design, you horrible computer. I probably am, but I don't care. The computer can't tell me that though. So, first thing we're going to need is a matrix to work on, because we're going to have to return a matrix, aren't we? So let's make one. Let's make the result. We'll just call it matrix. So that's just going to be mat4. And we'll just call it matrix. I'm not going to do anything clever. There we go. Right, so what's the first operation we need to do? Now, you've got to remember everything has to be done in reverse orders on matrices. So the first thing we have to do is to do the last thing, which is to place it in the world at the correct place. The first thing we should do is to scale it. The second thing we should do is rotate it whilst it's at the origin of the world, otherwise it'll do weird things. And then we can position it into the world at the correct position, and that will be our matrix. So we have to do it backwards. So we have to do translation, rotation, scale. Right, okay, so matrix equals, I'm going to do it in longhand, matrix times, and it's going to be mat4, and it's going to be translate, which we don't have. And for that we will use the translation that we've been given, that vec3. So we can use that vec3 there. We'll copy it. Dot x. There you go, it's there for us. We'll need a dot y. And dot z. Now we haven't written that. So we'll have to, won't we? So there you go. We'll do the writings of these at the end, but we do need that. What I'm going to do is I'm just going to go over to mat4 here, and where it says functions belonging to mat4, and I've started with that identity thing and was started here. I'm just going to pop down a few spaces, I think. Well, a space, and I'll just pop that in. So, and just shade it out for now. Save that. So we haven't got that function. We'll need to write it. That's okay. That's one to write. We'll need a rotation matrix by the sound of it, because that's going to be our next. Matrix equals matrix times, and again it's going to be a mat4 colon colon, because we haven't written these yet, rotate, and it's going to be 2 radians. Remember, we needed that function, we've just written it. And it's going to be rotation x, we'll put in this one. Yeah, rotation x. We'll pop in there. So that's now in radians, that's good news. And we are going to only affect affect the x value. So we are going to ask our function to only affect the x. And we're going to do that by putting in 3 more variables, x, y, and z. So that it doesn't affect the y, we'll put that to a 0. A 0 times any number is 0, so it won't affect that. And it won't affect the z if we put a 0.0 there. Are you okay with that? We haven't written the function, but I'm designing the function now. We're going to hand the function in radians, the rotation x, because that's coming in degrees, and I know it is. And we are then going to only tell the function to do the x value, don't do the y and the z. And that's a crafty little way of doing it. So all we need is 3 of these. Copy. I'll have 2 more lines, please, of that. And all it's going to do is rotate x, y, and z. So that becomes a 0. That becomes a 0. On the y, we only want the y value to be changed. And on the z, we only want the z value to be changed. Clever. I think we'll have one of those. There you go, there's a rotate. So, we'll need a rotate. There we go. That lines up properly now. Don't you dare put semicolon on the end. Alrighty. So that's 2 things we've got to do. So there's our rotates. And what did I say we needed to do first, which is obviously now last, scale. So this is actually pretty easy. This is an easy one for scale. So it's matrix equals matrix times. Did I squeal a little bit there? Oh, right, okay. Mat4. And it's going to be called scale when we do it. And it's just going to be whatever we put in as a scale. For the x, the y, and the z. They're all going to be scaled, well, at the same rate or by the same rate. So that's an easy one actually. We only need 1 of those. So I'll take 1 of those. And again. Just pop it in there and take off that semicolon, please. Notes should not have semicolons at the end. Yeah, that's it. So we're going to do those functions in the correct order, and then all we're going to do is return the matrix. And that's it. Complete. Next. This is that camera thing. Yeah, we need it. So it's a static, again, because we don't want people messing with it. So it has to stay the same, static means. Inline, mat4 is what we're producing a mat for. We are going to produce a mat for. We're going to call this function create view matrix, which we don't have. So we do need to create it. We have never created it. And I'll tell you how to do that. And that comes from entities. No, it doesn't. Where is it? Amber. Yes, it is. It's entities of the camera, isn't it? We're in Amber. So it should have it. Entities. Yeah, thank you. And it's our camera, please. Yay! Because our camera creates the view matrix. It's a view to the camera. Not from, but to the camera. We're working that way around. Don't worry about it. It's pretty precise. And we'll want a pointer for the camera. We don't want the camera itself. We'll just want a pointer to it, like an address or something. I could use an address, I suppose. Nah, let's use a pointer. We don't use pointers often enough, I think. There we go. Let's create this then. How do you create a view? Well, what will we need? We'll need rotations for the camera. And we'll need to know where the camera is. And there we go. That's all we're really going to need. We're just going to need the bits off the camera to create the view, because the view is what is that space that you can see on your screen. That is your view matrix. Your TV screen is your view matrix. So it depends on where you put that camera and in which direction it's looking. So everything has to do with the camera. So let's have a matrix again. So we'll just have a map for matrix. It's already an identity matrix, remember. I don't need to ask for one because we set it up so that it would already be one. So that is an identity matrix that I've got. If anybody is worried about that. So I'll do it in longhand again. So matrix, the first thing we're going to do is to do the rotations, I think. Yeah, we'll pop those into the matrix first. This one, it doesn't matter as much actually which order. That one, do it in the opposite order, and oh my god, it's a mess. It has to be in that order. This one, I'm not sure it's order specific at all. We're doing the rotates last. We're translating first. That's interesting. We translate and then rotate. It doesn't matter on this one, I don't think. So it's matrix times, and it's going to be map4 : rotate. I think we've already got that one. Yes, we have. Well, we will have. And it's 2 radians, because I kindly put that in. And it's just going to be your camera. And it's now a pointer to pitch, please. Get pitch. And that will affect, close, comma, the x-axis. So we are rotating, the pitch rotates around the x-axis, which is pitch up and down. Yeah, that's right. So that's okay. Rotating around the x-axis, so that's a 0.0 if and a 0.0f. There we go. Yeah, happy, joy, magic. In the last episode I moved this over and never moved it back. Thank you. We'll have to do it 3 times, won't we? So can we have another 2 of these, please? So it's going to rotate. First one's get pitch, then it's, if I can click in there without it giving me some stupid message. We'll need yaw. We'll have yaw. That will be a 0. That will be a 0. Yaw is the rotation around the y-axis. That is spinning around on the spot. Yeah, that's the y-axis. That's the yaw, correct. So that's pitch, yaw. And what was the last one? We had a roll. Let's roll with it. And that'll be the z-axis, obviously. Z-axis is into, so rolling will roll the screen around clockwise or counterclockwise, which is how you roll a plane. So think plane-wise, and when it does a barrel roll, that's what it does, or how it would look on screen. Woo, wheel going upside down type of thing. Woo. That's the case. What else do we need? We've got our rotates. need a translator, I suppose. So matrix equals matrix times a map4 : translate, which we will have written. I'll open the brackets. Translation is backwards. And it's going to be minus. Because the camera has to go in the reverse direction to whatever you want to see happen in the world. Think about it. If your camera rolls left, the world will roll right. So we have to minus everything here. So it's minus camera. And we will need to get the position. Get whatever position it is. Remember, the camera looks backwards. Think, think. Do everything backwards at this point. Position, and that will give us the next, won't it? Yes, it will. Oh, beautiful. Just have you again. Copy. And we'll do Y. Paste. We'll give us Z. I'm going to leave that hanging over. The length of that line is a bit much, I think. Now I'm going to do something special. Let's do that to there to there, so you can see it properly. Minus cameras, minus cameras, minus cameras. Get positions, get positions, get positions. Oh, and that's it. That's all we need to do. So the last line there is return matrix. That's all it is. It's it looks hard, doesn't it? But not when you've got it in words. Once you see it in practice, it's darned obvious. Why is this? Thank you. Good God. That's our toolbox. Okay. So we've now got our toolbox. It's up and working. It's hidden inside our math.h. Remember, I was using math.h, you know, everything, especially all these drawers here in the master renderer. I look in here, I should have maths.h, so it's already in there. It's in terrain, I hope. Maths.h, yeah, it's there. Master renderer. I haven't used it in here because we wanted something different. Oh, I didn't put maths.h in here. That's interesting, so why not? Oh, it's only because we need the window to do. Silly me. I'll check that though, because I'm not sure. We might need something else. I think all of that mathematics and toolbox stuff then is only for the drawers. I think the master renderer was just waiting for the window. Awesome. Makes it even easier because we've only got 3 things to write. I'm going to leave maths.h up because I want to make sure that all of these disappear. So let's do it. How? So we have it's inline statics we're using here, aren't we? Translate, rotation, and scale. Yeah, we can do that. So all we need to do is take the doubles out, put a space. And what I can do is I can do Shift-Alt down that lot. And for those 2 things there, I'm just going to type inline static map4. And then we need the proper variables here. So what we're going to have for translation, it's just going to be float xyz, isn't it? So that's going to be float. Delete. That's Y. And Z. Okay, I'm happier with that now. And that does need a semicolon at the end. No. Right, so that's good. Next is rotation. Inline Static Mat4 rotate 2 radians. We don't do 2 radians in here. So we will just have float angle in radians. Remember, always tell people what you are using. There you go. Oops, I put space in by accident because I was just typing it normally. Whoops. Float angle in radians, and then we have 3 floats which are X, Y, and Z. So we've actually got that there. To there. Float X, float Y, float Z, semicolon. Done. But that's important, as we said, FOV in radians, angle in radians, and that's why I needed that 2 radians converter, because I remember that in other places within our programming I didn't specify. So if I haven't specified, it means it's in degrees, because it's user friendly. Well, that's good for them, but not good for our calculations. So we've done that. Scale is the change. So it's that again. Scale becomes that. And I don't know if you know this, but we call it delta for change. It's standard mathematics, change is delta. So to indicate that, you can put delta. I just put dx, dy, and dz. That indicates a change because we're scaling. We're actually changing the value by a scale factor, which is dx, dy, dz. That is not a positional vector. That is a scale. That's a scaling vector. Okay, we got them 3, and I still got an inline problem because I forgot a semicolon. And I remember that, and I can never remember. I actually remember doing a mistake and never correcting it. That was clever of me. Right, what's up here? Nothing, thank you. So we now have 3 more Mat4s that belong to Mat4. So I can now take those, copy them, and we can just add them below orthographic. Yeah, here we go. Orthographic, I've got space, good. Just add them in. You can take the inline static off them all. This computer already knows that. And I will do it again. Shift, Alt, drag. And that will be a mat4 : translate, da. Okay, take that off. Take that off. Take that off. Brackets. Brackets. And brackets. All set up now, are we? I'm going to put an extra space in. We have the space at the end, good. Thank you. Save that to start. And let's do the translation. So we have a translate by whatever mat4 we get from a translation. So let's have a look at that and see what we get. Oh, I can't remember how to translate. Perspective I can remember. Scaling, rotating, and translating. Oh god, this is easy. Yeah, it is. It's straightforward. It's a rotate. No, it's not. It's a return. Sorry. See, fuddling Fuddling, fuddling, fuddling. Have I got any coffee in here? Yeah, good. Let's have some coffee. We need to return a mat4. And it's an open bracket. We don't want the identity matrix. Well, we do a bit. We want to change 3 values. So it's for translating. It's a multiplier, remember. It's 1.0 f, comma 0.0 f, comma 0.0 f, comma x, comma. Yep, that's right. Caps lock off, please. There we go. I want to be there. Will you stop hounding me with that thing? All I want to do is copy that to there, to there, and to there. Each one of these values then goes to a 0. And it's going to be 1, 1, or 1.0 f, and I think you can guess on this part x, y, and z. That turns it into, it turns a translation or your position in the world into a matrix, which can be multiplied by another matrix to add them together to compile it into a final vector. A final matrix, which is exactly what we've just done here. So that's how it works. Yeah, will that give us a translated matrix? Yes, it will. That is what a translated matrix looks like. Right, to rotate, slightly different. I think we'll need a calculation on this. Yeah, let's do a calculation on it. Mat4 result, that's the identity matrix. I'm going to need the cosine, so we'll call that C. Cosine, float please, the float version of it, and its angle in radians. There we go. When you rotate, it's in a circular motion. What we have to do here is use that circular motion and the equation for it, which is sine and cos. So I'll need a sine. You have to put your sines and your coses in the right places. And that's how it's done. It's very simple, really. But it's just copying out whatever they give you on the internet. And that's just going to be angle in radians again. What else will we need? We'll need a constant, which is the opposite to the cosine. We have to, in that equation there is a negative cosine, so we'll need one of those. Float, oh, I'll call it OMC because that's its abbreviation for the long worded version. OMC, 1 minus the constant cosine. That's what it stands for, 1 minus cosine. I could put it in full, really, I suppose. I can remember what an OMC is, I can work it out. So it's 1 minus the cosine, which is C. Right, let's do this. Result, well, we'll do it bit by bit, so we'll do column 0 first. I'll do it in columns. result, and it's going to be dot R0 C0, and that's going to be equal to something. That's not a 0, that's an O. I want zeros. Dope. Right, we're going to need a lot of these. We need to alter 3 values in each column. So do each 3 values from each column. And it's going to be row 0, 1, 2. So we're going to cross on the rows. So row 0, 1, 2. Column 0. Same thing here. 1 and 2. That's for column 1. And of course this is column 2. Yeah, I'm making it look easier now. There we go, altered. They're all altered now, so we've got column 0, column 1 and column 2. That's column 0, column 1 and column 2. And we're just going to alter the first 3 values in there. Obviously, when you rotate, you don't want to mess about with that bit. You don't want to mess about with that bit. Alright? Because we've just shown that that's for translation. This square inside, this 3 by 3 square inside, is for your rotations and scaling, actually. So you'll find out we'll do the scaling is a 1, 1, 1 in the middle, by the way. So these will go something like this. X yeah, float x times 1 minus the constant, and is it plus or minus? Yeah, that's plus the cosine. There we go, that's that one done. Looks a lot better if we do it this way. This one is the y, and that's times what we just put in, which is x times OMC, and then we need the factor, which is plus, and the factor in here is z times s, the sine. Yeah, make it more readable. Yep, so we've got x times the OMC plus z, which we haven't used, times the sine. Yep, that's correct. And the last one for this area is z. Obviously it starts with z. I think you worked that bit out. And then it's times x again, times your x by your OMC. Always do x times OMC in this part. And the constant value here is the one we haven't used, which is y, and that is just times the sine to get your circle. There we go. Lovely. That's got our circle going there. So on column 1, we have to do exactly the same equation, but now we have to do it for y. So x was the major here, so we can do the y one first, and you'll see what I mean. Y times OMC, and that is just plus c. So that's that one. And I bet you can guess what this one down here is now. It's z times OMC plus C, semicolon, not a colon. Right, so we've got those out of the way with. Oh god, it's these other lines. You've got to get your pluses and your minuses right now. I've already got one wrong, haven't I? Because you have to do a minus y on that one. Looking at the equation, does it work right on 0? ZX, OMC, YS, yeah. So, this one is going to be X. Alright, so it's X. Oh, I can't do it there. Never mind. X times Y times OMC, of course, always is. OMC, and then do we plus or minus on the Y? We minus a Z here times, and that's your sine of the angle. Looking good. Z times, which one haven't we used? Y again, isn't it? Yeah, we can always use the same one on that part. Y times OMC. Do we plus or minus the X? Plus the X. X times S. This should be easy to memorize because it's a pattern. As you've noticed, I haven't memorized it. Can't understand why. Now this has to be different from all the other X's. So I've used Y, so this must be Z. And of course we have to times that by OMC, 1 minus the cosine. And then we have to add the one we haven't used, which is the Y. And that is just times the sine. That's always the same there. And of course we haven't done Y. And we'll use the same again, so it's times Z times OMC, and I think it's minus here, is it? Yeah, minus X. X times S. There we go. And that's how you rotate. Warning, when you're looking straight up or straight down, you may gimbal lock, because it won't know which direction it's facing. That's just a warning. I'm hoping that that equation will stop it happening. We'll find out. It's something I am going to be looking at. A gimbal, by the way, is something you use on the camera to make sure it remains straight up or straight down, you know, level, straight level, when you are moving the camera around. And it's a gimbal mount. And a gimbal lock is when you lock it to straight up or straight down. And that would mean that your camera would incapacitate itself. So you'd be moving it around, you'd look straight up, and whoops, locked. Reload game. Yeah, not good. Not good at all. Oh, we haven't returned it, have we? Ah! We didn't return result. We better, how do you know? We'll get angry. There we go. We're looking in MathState now. These really should start to go away. Go away, you horrible little things. I'll see about that in a minute. They are part of map 4, aren't they? Yeah. Yeah, that's right. Inline Statics. I don't know how it's going to handle this. Just save out what we've done, just in case I make a complete cobbler of the last one. Looks awkward, doesn't it? But it's just thinking through. Horrible, 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 horrible. That is actually a ball. The inside of a ball. That is the equation for it. Yeah. As if we all want to remember that. Let's do an easy one. Scale. Return, because it's the last one. Return a map 4, please. I'm just going to open the brackets on this. And this one is going to be very easy. It's going to be dx comma. Oh yes, I know how to do this one now. Come on, up it, 0.0f, comma, 0.0f, comma, 0.0f. We only want the dx there. That's right, because we are creating the scaling mat matrix. That is correct. Comma. Ding. Copy. That to there, to there, to there. Dx becomes 0.0f. You can already see what I'm doing. As I said, the scaling is all done by that diagonal 1 that we kept putting in, which is why it was very important to put a 1 there. You can't put a 0 in the identity matrix, because if you did, you wouldn't have a scale. You'd have nothing. Yeah, you just have literally nothing. So we're going to delete this and put dx and it's dy. And then we are going to just, thank you, go to this one, put a dz in please. Yeah, okay, and this one has to be changed to a 1, doesn't it? It always has to be a 1, no matter what. That's our homogeneous thingy. Lovely, that should work. Oh, magic. That's our maths done. How are we doing for the time? Oh, I've done well. I got it less than an hour. Wow, less than an hour to complete your maths. Semicolon. Semicolon. I'm happy, happy, happy. Joy, joy, joy. Joy, joy, joy. Joy, joy, joy. I'm not checking all of the maths though. Joy 2, yeah, alright, yeah, I remember that, that's good fun. Done, done, everything is happy up here. Saving this out. Done. Now, I'm going to check for the way I've used it. And it should be mat4, colon, colon. Where's translate? T. Yeah, it's there. Translate. So it's right. Why can't I multiply it? No operator multiplier matches these operands. Operand types are amber mat times amber mat. Well, that's an amber mat times that's an amber mat. What's it talking about? Interesting. It's done the same down here. So we don't have a multiplier. Do I need a multiplier? Matrix and vector, left and right for the mat4. We do. We need a multiplier. Oh, wow. I didn't realise we'd have to do that. Because remember, I haven't done any functions belonging to the system. Well, that multiplication belongs to the system, and of course we've just buggered it up. So we are going to need an inline. I'm going to do both. I'm going to do the vec4 one first, because they're both very, very useful operators to have. Multiplications, for instance, and it's going to be the times operator. This is going to be a const mat4 and the address of a matrix, comma, const, and we're timesing it by a vector, aren't we? So it's just going to be a vec4 and vector. So we'll do that one. I thought this was going to take over an hour. Vec4 I can't have. Why? We haven't got it included. And that is going to be... No, I want the vector 3. I don't want that. Vector 4. I'm not doing it. We're not using vec4s. No. Alter this at a different time when we actually start using vector 4s. Better idea. So instead, we just do the inline mat4. Ooh. No, I'm not doing an extra file just for that one line. And it's going to be the operator star, open brackets, and it's going to be const mat4 and left side of the equation, times a const mat4 and right side of the equation. So left times right. That should do it. Now, where am I going to put that? We can just put it at the end of these, can't we? But I'll need a squiggly. I need some squiggly lines or something to denote that we've got to the end of these. Does this stay inside or outside? So it's return mat4, close. I want to go here. I think I have to stay inside. 1 second. I'm going to double check that. Yes, we do. Yes, we do. We have to stay inside. The thing that we don't do is put that mat4 : on it, because it's not a member. It's part of the operating system. So it will be mat4 as the outgoings, and then we can just put the we can put it in straight, can't we? Yeah, we can. So it's just going to be that literally without the semicolon. Copy. It's going to go there. So that's going to be... Oh God, what have I done now? Oh dear, get lost. Missed it, didn't I? V, thank you. Return, thank you. God, fathers. I want a splitter. Because it's no longer... so these are system. Operations. This is the multiplication operation from 2 mat4s. There we go. We're off. We're off. How do we do this? Oh my God. OMG. Okay. Jesus. I can remember doing this once. I'm just wondering whether to type this in very fast and let you copy it, or whether to just say yikes. Because the answer is stupid. Here it is. I'll type it in very fast for you. And I'll only ever do this once, because I type in every line, as you know. But this, once you've typed it in once, you will never ever in your life type it again. Yeah. Let's just have a look at what I've done. I'm creating a new mat4 with as an identity, and then I'm filling in that mat4 with all of these values. And you have to take every single value and multiply it out. So it's 2, it goes on 1 value plus another value, then it's plus another value, and yeah, then it's the comma at the end. Then you do the 4 values going across, 4 values going across, 4 values going across, 4 values going across. Oh, and every single line is slightly different, as you can see. 0. You see how it starts here? So that's 0, 1, 2, 3. On the right side it goes 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. And then you put the plus in, and then you put in C1, R1, C1, R2, C1, R3. You see, you just increment the C for each of the lefts. You do the same for the left here, you just increment the C for the lefts. You do the lefts and you increment the C for the lefts. On the right hand side, all you're doing is 0, 1, 2, 3 for 0, and then you're doing 0, 1, 2, right, 0, 1, 2, 3 for 1, and then you're doing on the next right for 2, 0, 1, 2, 3, 1, 2, 3, yeah, and then for 3, row 3, 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. There you go. Oh God, that's a killer to type in. It's actually just the first line copy and pasted. And then you just go down each line and you change it in the correct order for the correct sequence, and it works beautifully, and it's fantastic. And it'll take our maths and it'll say, yay, we can multiply. There you go. You just experienced the worst part of the maths programming done in a couple of seconds, and I hate it, I hate it, I hate it. I spent a week typing that in. Yeah, because I'm an idiot. I'm happy now that all our maths toolbox is correct, and we've now got something new included in our math.h. So there you go, it's our toolbox to just add maths functionality of 2 radians, creating a model matrix, and how to create a view matrix. This has added and extended our mat4 to include new things here, which are a few new functions. Let's get back to the beginning of this. Here we go. Which are translate, rotate and scale. We already had perspective and orthographic. And we've also added the multiplier, matrix times matrix multiplier, so that we can do the calculations. There we go, all done. Hope you're happy. I know it's complicated maths rubbish, and I don't like this video. Never have liked doing this kind of video because there's no way I can take time out to explain all of these equations to you and how it all works. And that to me is bad. The video's pretty useless to people. Just copy it down and never do it again. Funny thing is, this maths library will never be typed in again. I'll just copy the whole maths library over to a new project. It is the way I work, and I do have the other parts of the maths library, I just haven't shown them. I don't like typing them out, but if I do place them in here, I will at least type them out and go through them once more, just for you, viewers, because I think it's only fair. It's just things like that mat4. I mean, the vec4 operator multiplier is similar, but a lot easier to do. I mean, that's only 4 lines of garbage rather than, how many was it? 4 times 4, 16 lines of garbage. Yeah. What are we up to? Draw entity, which uses our toolbox. Ooh, I'm getting excited now. Hey, let's do it. Let's actually do it. So next episode 19, will be draw entity, and we're going to be using our toolbox to do that. I've just modified a couple of things, haven't I? So I've modified that, and I've modified that. We should just, yeah, that's right. Okay. Maths updated. And I'm just going to name that toolbox because that's what I call it. Because it is. It's a little toolbox of maths to make things easy for us on the next couple of episodes. So I'll pop that out, and we'll have that. Okay. Happy. catch you in the next episode. So everybody take care. Oh, yes. Just remember, have fun.